For the next section, we're going to go through some key concepts of using GMAT. There are two parallel interfaces within GMAT, the GUI and the script. These are nearly interchangeable, but not totally, meaning that some features are only available in GUI or script. On the left, you'll see the GUI resources tree, and on the right, you see a script. To start, let's look at the parts of the script editor. The script editor window is located in the center of the screen. This is where we can edit our active and inactive scripts. To the left of the script editor, we see the resources tree, which will have a list of scripts that are currently open in GMAT. Note, the name of the active script will be bolded. Back to the script editor. The script editor window shows us if the script is active, the save status, and then shows us the file controls and synchronization buttons. An important note here. If you make a change to your script, you need to click the Save Sync or Save Sync Run for those changes to be reflected in the GUI. The same is true in reverse. If you make a change in the GUI, Resource tab, or Mission tree, you need to save by clicking the floppy disk save icon in the top left corner underneath Edit. This will synchronize the changes made in the GUI back to the script. Knowing whether the script and GUI are synchronized is important, and as such, the status is shown in the indicator above the script editor window. A GMAT script is a text file consisting of valid script syntax elements, such as initialization statements, mission sequence commands, and comments. At the highest level, a GMAT script is made up of two sections, initialization and the mission sequence. These sections each contain statements, but they have different rules about what sort of statements are valid. The initialization section maps to the resources tree on the GUI, and the mission sequence maps to the mission tab in the GUI. The begin mission sequence command defines the beginning of the mission sequence section. The script you're seeing on the left is a screenshot from the native GMAT script editor. One helpful feature of the script editor is syntax highlighting. For example, command text is shown as blue. There are a few scripting element categories that are useful to have knowledge of. First, we have resources. Resources are participants in a GMAT mission. You can think of them as classes in object-oriented programming. Resources are classes with properties or fields and represent things to manipulate. So, for example, we have a spacecraft. We can manipulate its orbit, or add a tank or define a thruster and attach it to a spacecraft. A report is also a resource. We can write data to a report. Next are commands. Commands are events in a GMAT mission. Commands represent the actions taken on the resources. We can think of them as functions or methods. For example, create is a command used to create resources. Report is a command used to write data to a report resource. Fields are properties you can set. Many times a resource's fields are static, such as when you set up a spacecraft's initial state. The time or epoch associated with that initial state does not change. Another example is thruster.decrement mass. This is a true or false that sets a setting in GMAT. Thirdly, a file name is a static field, which is set in order for GMAT to write to that report. By comparison, parameters are properties that GMAT calculates during a mission. In the example, spacecraft.earth.altitude, GMAT must calculate the altitude at each time step during the mission sequence. Sometimes a property is both a field and a parameter. For example, spacecraft.sma can be set as part of the initial state and can be calculated before or after a maneuver. Again, these are all just some categories of scripting elements to help you better understand how GMAT is programmed. Now, let's identify how different scripting elements are shown in GMAT's native script editor. Command text is colored blue. Almost all of the time, the only command in the initialization section will be create. In the mission sequence, propagate and write are commands. Propagate tells GMAT to move the spacecraft through time, and write tells GMAT to write a value to the message window or a report. In the initialization section, resources are identified by green text. On line 1, we see that we are creating an instance of the spacecraft resource called ASAT. To drive the concept home, ASAT will have all of the fields associated with the spacecraft resources class. and they will be initialized to the default values. Similarly, in line 5, we are creating an instance of the propagator resource called aprop, again with all the propagator fields set to their default values. In the mission sequence, we use a command with a resource. In line 16, we use the propagate command to call the aprop propagator resource to propagate ASAT to periapsis. More on this syntax later. There are two fields shown in the script. SMA, or semi-major access, is a field of ASAT. The file name is a field of a report and is set by assigning a string to a report.filename. Note, file name is a static field that will not change. However, SMA can be a parameter in the mission sequence. In this script, there are 3 parameters shown in the mission sequence. The first, in line 16, is periapsis. Used here, periapsis is a stopping condition for the propagate command. So GMAT will propagate the spacecraft until it reaches periapsis, but it's a little more complicated than that. Many times parameters have dependencies. Dependencies tell GMAT what it should calculate the parameter in reference to. In this case, we want to know when the spacecraft reaches periapsis around Earth. If we do not define a dependency, GMAT will use a default. In line 19, the write command tells GMAT to calculate and write the altitude of ASAT with respect to Earth. In line 22, we tell GMAT to calculate and write the altitude of ASAT with respect to Luna, or the Earth's moon. The key point here is that if a dependency is not defined, GMAT will use a default, which may be incorrect for your use case. Like we talked about before, scripts are divided into 2 sections, the initialization section and the mission sequence, which are separated by the begin mission sequence command. Now for some notes about GMAT scripting language. Numbers in variables and arrays are always double precision. Resources need to be created before they are used, except for certain system defaults that are always initialized. GMAT scripting is case sensitive. You can see a capital and lowercase y in the statement in line 13. GMAT uses begin and end block statements. Shown here is the if statement, followed by the end if statement. Similarly, syntax is used for while, for, target, and a few others. The script has single line statements with optional line continuations. Shown here, we have the write command being continued with ... to the next 2 lines. Let's look at differences between the initialization section and the mission sequence. In the initialization section, we are only allowed to perform static assignments. Line 5, 6, and 7 show x equals 1, y equals 2, z equals 3. My string in line 9 is assigned to be hello world. In the mission sequence, we can start manipulating existing resources. For example, we can do math assignments, shown in line 13, or we can use comparison statements, like the if statement in line 15. Remember, we cannot create new resources in the mission sequence. Math syntax in GMAT is based on MATLAB. If you are familiar with MATLAB, this should be pretty simple. Like MATLAB, math functions are matrix aware. As long as you have a valid matrix operation, you can add 2 matrices together, multiply, transpose, etc. There are also a number of built-in math functions. The list here is shown here: sine, cosine, tangent, degree, radian conversion, etc. Just a reminder that when using math, you can only perform evaluations and manipulations in the mission sequence. If you try to do this in the initialization section, you'll get an error. A little bit on control flow. GMAT has 3 control flow statements: if and if else, while, and for. Here is an example of an if else statement. Note that there is no else if statement. Next on the right, we have a while statement. Notice in both we have our end block to end the control flow statement.